Let's go to our base level. Yeah, so if you remember what we did last time was we created this level where we have our beautiful cylinder who is saying that they're so lonely. And then if we move our character close to the cylinder, it says, "Why are you so close?" And it runs away from you in a random direction. But sometimes it'll run at you because it doesn't really take into account the direction in which you come from, just the proximity. But still, that's what we kind of got to, the very basic behavior that we built up last time. And a lot of that comes from our Blackboard. We have our behavior tree. Oh, we have assets open. Right. Let's open some tasks for us too. Okay, so now we have the behavior tree and the Blackboard open. So our behavior tree is quite simple, but you can see I wrote a bunch of comments because we were trying to learn from it. Oh, really, Bray? That sounds great. Unreal style. Right, we're not a fan of behavior trees, says Brainoid, yet, but we're trying hard to like them. Yeah, we try hard to like many things about Unreal, don't we? Oh, by the way, I've mentioned this to a few people, but Pluralsight have a free weekend tomorrow, Saturday and Sunday. You can access their courses for free. I have no affiliation with them, but I used them before to learn web dev and some just learning Java after I'd not done it for like 10 or 7 years or so. And it's good. It's a subscription based learning platform where you pay like $20 a month and you can use any of their courses instead of what Udemy do is you pay per course. But obviously it's good value if you like binge learn. But if you like to do like an hour a week, then it's not a good financial plan for it. Anyway, they have some Unreal courses. Some are quite old, but there's lighting ones which are quite like 5 years old. However, I spoke to some people in work today and they said like the lighting hasn't really changed in Unreal in the last 4 or 5 years anyway. So it'll still be relevant. So I'm interested. There's an AI behavior tree 1 or 2 up there. And then there is also one about lighting that I'm interested in looking at because that's going to be one of our topics. And if you remember last time we had AHA open, I was trying desperately to make the shadows less shadowy, right? To get some more ambient light. And I always struggle with the light. So it'd be good for me to look at it again because I have looked into it in the past. It's just so long ago and I don't use it. I want to revisit it. There's stuff on materials as well if someone wants to learn about those, but we've done a session on them now, so I don't feel that would be so good for me. Oh, and there's a UI one. There's a UI course. There's making yeah, there is. There's definitely a UI course as well. I was going to look at that too. Okay. Personally, my own real gripe with them, says Hefu, is the interaction with Blackboard. Yes, that's what Brainoid hates about it as well. Blackboards are so in the middle of that logic and turns me off. Like I don't feel like I'm using that logical structure. Yeah, it feels really jank, doesn't it? It feels like you just got to give it strings and say, "Hey, you have a variable called this. You have a member called this." Yeah, it feels a bit clunk, but anyway, okay. So let's officially get started, shall we? I think celebrate started. Oh no, don't I have it anymore? I used to have a full giant pink elephant, my logo in pink, from when I did Valentine's Day, but I don't know where it's gone now. Oh well, we'll just have Banana Dog up for it, shall we? Right, let's get started. So what we did last time, let's revisit what we did. We've seen what it does. So we've made behavior trees, and I've disconnected these because we were just trying them out one by one. So first off, we just made a simple sequence. So with a sequence, all sub-steps need to succeed for this to succeed. And that's why we normally have a selector at the top, because the selector will stop when any of its children succeed. So if you've got this tree-like behavior coming out, it'll try all of your branches, which tend to be sequences, at some point or the lower point. And then if they succeed, that's it. It doesn't go and evaluate the rest of the tree. So it'll just do one of your behaviors instead of all of them at once. So that's the general flow, is that we have this selector at the top, and then we branch out, and the tree will try and traverse through until it gets to this selector gets satisfied. But remember, some of these tasks They're not. It's not like every frame this gets called, and that's something that I initially was confused about. This isn't getting like called every frame, because if we're in a task, say we have a task, get random location. Let's say this takes a while to do it, or this move to is a better example. Sorry, this moving, it's not going to just move one tiny bit and then reevaluate, and if it comes in here it does more. This will actually make a task where you say, okay, I'm going to move over here up to there at this speed, so it's going to take me maybe 3 seconds, and I'm going to move there. And then once it's finished, once it gets to its destination, this task gets marked as complete, and that's when the tree traverses back up. So it's not like every frame we have an entry point here. The tasks and what you're processing in the behavior tree is detrimental to the flow of things as well. So yeah, we first looked at sequences, and we were just trying to do a simple move to. So that works fine. Give it a target location. So what is our target location? We've made a key on our Blackboard. So Blackboard is basically your brains, where you store variables or shared data between different nodes in your tree, different branches, different tasks, or the actual tree itself. And you can pass values from your Blackboard into functions. You can, like, as in, you can access them within your tasks, but you can also write to them within a task so that they're then accessible after the task is run. You can save the information out from a particular task. So our Blackboard, we have just something called target location. And so we use this as a way for us to cache, to save where we want to go. So here, target location, that will literally just go to whatever my target location is. And by default, if we go into our Blackboard again, I think we don't give it a default value. So it'll just be 0, 0, 0 on the map. That's my understanding about it, right? So then we wanted to get to a point where we actually set that ourselves. Now we did find this move directly towards, and what we found about that is it's the same, but it ignores nav mesh. Okay, so that's we don't tend to use that. Well, we're not going to tend to use that as a result of it, but there might be some reason why you would want to use it. Okay, so the next thing we did was a basic behavior with no custom tasks. We're using tasks that exist already in the base function, behavior tree kind of library, and we're controlling the flow with a decorator here, which has a notify observer step. So that's a lot of little steps that we got to talk about here. So first off, we have our sequence. This would have typically been plugged into this selector up here, right? And within here, we're basically saying do the following, but because it's got a decorator, this is an if statement saying do we go into it, essentially. And what this says is can follow target is set. So you choose which Blackboard value out of the 3 that you created. You make new ones, adding new keys up here if you ever want to. We are just checking a value, and we can either choose is set or not set. That's because it's a Boolean. Because it's a Boolean, is set and not set is our way of saying is it set to true or is it set to false. Don't know why they didn't use true or false, but there we go. So we're saying if can follow target is set to true, then we want to move to that location. Otherwise, we're going to just wait half a second. So what else have we got here? This task will come in and keep executing until it gets to its destination. Yes. Cool. And then this won't happen until move directly towards has finished, meaning it's got to its destination. Oh, sorry. This isn't an else. Let me rephrase. I said that incorrectly. This sequence will do both of these things. So as long as this is true, it will move to, and then it will wait for half a second. And then it will move to this target location. So it would need to update our that during execution for it to move more than once, really, because otherwise it's going to be at that destination already. Yeah. So Brainerd in chat saying sequence is like an if, whereas a selector is kind of like a if, else, if sort of process. Okay, so the main thing that's interesting here, I guess, on the decorator is also this notify observer. So what this is saying is if this variable that you're tracking can follow target changes, then we should break out of the flow of this. And that means I could be midway through moving, and if I set you can follow target to be false midway through, it will jump out of this. It will cancel what it's doing, and it'll go all the way back up the tree, I believe. It may go up out of this node. I don't know if it starts at the top of the tree again or whether it will just fail this, but I think it reevaluates. I'm not 100% on that. Okay, so that was one way we did it, and these are two nodes that already exist. So the next thing we then did was a custom task to get the location of the player, move towards it, and wait 5 seconds. So any of these ones that we named BT task or BTT, we ended up starting to call them just because their names are horrid. But these BT tasks, binary tree tasks, are custom tasks that we've made. So first off, we find an actor location. We've made a better version of it, so we have two. So this one nothing's happening with that one. Then we move to that location, and then we wait for 5 seconds. And if the player moves, then when it goes back to this phase, so it'll go through this, it'll find a location, it'll start moving towards it. Once it gets to that location, it waits 5 seconds, and then if the tree comes back down this route again, it'll start again. And it'll go, okay, where's the player now? So if you move in between, it'll then get that new location. One thing it's not going to do is it's not going to update when the player moves. So if it's midway to the player's location and then the player runs away, it's not going to change the trajectory of this AI. And the reason for that is because there's nothing interrupting it. We're not changing it. We could put maybe a decorator on it that monitors whether or not that location of the player is changed. But I'm sure there's better ways to do that as well. So let's have a look how we did these tasks. These are existing ones, so this is the only new one that we've got. Double click this, and this is our very first revisiting of a custom task. And when you make a custom task, you have to have two nodes in your graph. You have your event receive execute AI. So this is basically saying when the behavior tree passes in, like gets here. So when this arrow gets here and the flow is leading in, then we want to do stuff. And then at the end, you need to return this node. You can return success or fail, and that will denote whether or not this task is determined as success or a failure. So if it returns a success, because it's a sequence node that keeps going through, it will then carry on and go to the next one and go to the next one. However, if it returns if it fails, or so it doesn't return that success, then it's going to cancel at this point, because the sequence, as we remember earlier, up here, all substeps need to succeed for the sequence to succeed. So as soon as one of them fail, it's going to back out of this tree, this branch, you could say, sorry. Okay, cool. So let's have a look how we did that. Random location. Was this definitely the right one? It's the second one. See, okay, so first off we say, hey, can you cast this into an AI character simple, which is the class that we made? We can. If we can't, we want to return not successful. And so that whole tree will fail. Because if they're not that type of character, we can't move them anyway. Then what we do is we go ahead and get this character and has a member called target actor. And that target actor is just a member variable that we set manually. First we say, hey, I got your flowers. Said, wait a minute, Sally. I think I've got something in my teeth, Brainoid. Could you get it out for me? Tenacious D. Let's go into our blueprint and have a look at this character just so we can see what's going on with this. Why do we have two of them called AI character simple? AI character, AI control. Oh, one's the controller. There we go. My eyes were not looking properly. So what did we cast this to? We casted it to a character. So let's look at this character. This character will have one member somewhere in here saying target actor, I think. So let's try and find that. Is it maybe, did I make it an edit only member? I probably made this in Blueprint. So target actor over here. Yeah, you can see we do have this target actor member. And so we set that manually. I think, did we do it via the level blueprint? Nope. Can't remember how we set it. Did I do it via the controller? Yeah, we may have. I think I did it when I pressed the button, didn't I? Yeah, okay, on key press K, we were... Oh no, that was a different thing. Ignore that, sorry. Okay, here is when you press K. or was it K? Yeah. It will set a value on, no, that's on our binary, that's on our Blackboard tree. So that is setting can follow target, which is what we saw in this decorator up here, the can follow target. What I'm looking for is when I set this, oh, I think I know what it is. I just manually set it, if I remember correctly. So if we go into our this, we should be able to see on this that we've just given it an actor, target actor this yet. So we've given it this other actor as its target, which is why it would follow it if we had that hooked up. That's flipping Tim Budet's work. Tim. And hello there, Euromaster. How you doing? Okay. So we were revisiting this task. So it checks that member, and it here what we have is setting a variable value, and we're going to use this to write to a Blackboard tree. So to the Blackboard tree, sorry. So you can see we're getting a location from wherever that actor is that we referenced in our AI character. So let's just look at this again. In here we reference this ball, and we're asking it, hey, get your reference to this actor, and we want to get the location from it. Gets the location from it, and then we're setting a Blackboard value as a vector. So you can see what we've got here. This is a Blackboard key, and we've just given it a name. It does, at this point, it does not need to match up to anything you've got here, which is why I made an effort to not call it the same thing. So we just called it, was it character vector or something like that, or location vector? We'll have a little peep at this again now. So within here, we called it new location. That's the one, sorry. So new location does not exist there. But what happens when you name one in this way, when you say this is a new location, it's a Blackboard key, we're going to assign it. When you use this node here, what that does is expose out from this task a way for you to allocate this. So you'll see now we'll have new location as an option. When we go back here, we go into the behavior tree and we click on this here, new location. And this is where you get to choose actually what you want it to map to in your Blackboard, in your list of variables. So we're going to set it to the location where we want to go. So we click on there. We say, okay, whenever I set something called new location within this task, we're going to allocate it to this Blackboard variable. So it's going to get written to it. You're basically passing it in. The way to think of it is, if we go into this, we're actually, it knows about it at this point, right? You're passing in a key into this member, into this kind of parameter here, so that when you get to this point, it knows how to write to it. It knows where to write to. So yeah, that's our way of writing data back out. And what that means is when we try and move to target location, then we then have an updated location. Okay, cool. So we did that, and then the final, other than the the latest one we did, was this, which is where we created a custom decorator to compare distance between AI pawn and the target actor. So here you can see that we got a BT decorator prefix on these. So these are custom by us rather than the one we saw earlier, Blackboard base condition, where you just check the value of a Blackboard member. That is built into the system already, so we didn't have to make that. These are new though. So I just added in some print statements to happen based on these. So this was essentially, this is just a distance threshold check. So it says if you are underneath 200 units of distance or below 200 distance away from me, then it's going to print out this message with the debug message. Otherwise, we're going to inverse it. So we saw there was an option to inverse a condition, which gives you that nice reverse logic for free, which is cool. We haven't taken care of the situation that it could be less than or equal to. So if you got exactly 200 units away, it would not say anything. But yeah, so let's have a look how we made that decorator, shall we? So the decorator itself looks a little bit like this. So what we learned is that we had to, when we make a decorator, we end up making a function. So we haven't got anything in our main event graph. Thank you, Imarana, you're free for your advertisement. I do want to become famous. How did you know? But yeah, so what you need to do is create this function here. Perform override condition. So you make this function, and then within here, I think it's just the name of it. Can't even remember if I specifically overrode it or just created it myself. But we create this function of this name. To be honest, I think we might have overridden it because that's how it knows what actor. It knows that it comes in with something, right? And basically, we have our same way here of just returning something out from this. So we want to get our. We're just going to be returning a true or a false, effectively. Because if you think about it, when it comes down to these, they are just a true or a false. Do I get to go past or not? So if we think about it that way and go back to our node graph, we can see that if this returns false and no tick box, it means that you're not going to get that past that bit. Where this means this then is based on the logic that we're trying to figure out here. So let's follow it through. So it first says, okay, the owner, can we convert that into an AI controller? Yes, we can. Can we get the control pawn from that? Yes. Can we cast it to an AI character symbol? Yes, we can. Then what we need to do is to work out the distance. So remember last time we were just getting the location of the actor, which is our target actor. This thing, do you remember? Now what we're going to do instead is use that same location, but we're going to subtract one from the other in order to get the distance between them. So we get the vector length of the resulting subtraction here. And then this will be our comparator to a distance threshold. And if you remember, this special name here is a member that we've exposed out with this little eye icon. And if we pop back to the main behavior tree, we will see this is why we get to write in this value in here. So this is where we choose what number we want to be used within the logic. Wrong tree, sorry. So it essentially says, is the distance between us less than or equal to what your threshold is? So if it's less than, it's going to return true. If it's or equal to, sorry, and if it's anything more, it's going to return false. Or of course, if we couldn't cast or anything. So that's why we were then able to do. So this means it's close enough because we said if it was less than or equal to. And then this is inverted. So all I've done is the exact same setup, but I've ticked this tick box here, and that gives us a reverse situation. Okay, sweet. So we're on to the last one. And hello there, Nalhaj. I could have been famous, and now the opportunity is gone. Okay. By the way, going through all of this, it does make a good summary for anyone who wanted to watch, but it helps me a bit as well. That's why I like to do these. I think it benefits everyone other than those who know it all and are impatient to get on to the new stuff.